Namaste everyone, welcome to the class again. Now let us see the fourth question. A manufacturer produces nuts and bolts. It takes 1 hour of work on machine A and 3 hours on machine B to produce a package of nuts. If it takes 3 hours on machine A and 1 hour on machine B to produce a package of bolt, he earned profit of rupees 17.5 per package on nuts and rupees 7 per package on bolts. How many packages of each should be produced each day so as to maximize his profit if he operates his machine at the most 12 hours a day? So a manufacturer, he is producing two products. One is nut and bolt, and for producing nut and bolt he require machine and two type of machine A and machine B. Their requirements on machine is given, their profit is given. We have to find how many package of nut and how many package of bolt the manufacturer will produce so that he has maximum profit. So here let us consider, let manufacturer produces X package of nuts and Y package of bolt. Let Z be his profit. Fine. Okay, so first I will write the given information in a tabular form. So I will say given information in tabular form. I have nuts and bolts. We require two type of machine A and machine B. Machine A, so nuts, we are producing X unit of nuts and Y unit of bolt. So on machine A, to produce nuts it takes 1 hour on machine A and 3 hours on machine B to produce a package of nut. 1 hour on machine A and 3 hours on machine B to produce one package of nuts, and it takes 3 hours on machine A and 1 hour on machine B to produce one package of bolt. Now regarding profit, when we produce one package of nuts, the profit is rupees 17.5. So profit here is 17.5 and here profit is 7. This is his profit. We have to find number of and the total time for machine is 12 hours a day. So machine A operate for 12 hours. So this is total. Okay, so total time is 12 hours. These are also in hours. You can mention unit, you can mention, or if you will not mention unit, then also it is fine. And this is profit in rupees. So we have to maximize Z. Here our problem is to maximize Z is equals to, now the profit will be 17.5 x plus 7y. This is profit we have to maximize, subjected to, now the different conditions are subjected to this. First condition will be x plus 3y less than or equal to 12. So maximum time the machines are available are 12 hours. So this is total time. Okay, I use on machine A. I will produce x unit of nuts. 1 unit of nut require 1 hour on machine A. So x unit will require x hour, and 1 unit of bolt require y hour on machine A. 3 hour on machine A. So y unit will require 3y's. So the total x plus 3y, it should be less than or equal to 12. Similarly, 3x plus 1y should be less than or equal to 12. Now we have to maximize and subject it to these conditions, plus the package of nuts and bolts, they cannot be negative. So x comma y greater than or equal to 0. So this is our problem. We have to solve it. Now you know in first exercise we have done how to solve this kind of problems. So easily you can solve this problem, right? So let us move to next problem. Formulation is important, that I am showing you how to formulate it, how to solve it, that you know you can solve. The next problem is, a factory manufactures two types of screw A and B. Each type of screw require the use of two machines, an automatic and a hand operated. It takes 4 minutes on automatic and 6 minutes on hand operated machine to manufacture a package of screw, while it takes 6 minutes on automatic and 3 minutes on hand operated machine to manufacture a package of screw B. Each machine is available for at most 4 hours on any day. The manufacturer can sell the packages of screw A at a profit of Rs 7 and screw B at a profit of Rs 10. Assuming that he can sell all the screw he manufactures, how many packages of each type should the factory owner produce in a day in order to maximize his profit and determine the maximum profit? So a factory manufactures two type of screw, A and B, and we have to find the number of package of type A screw and number of package of type B screw to get the maximum profit. So I will say, let factory owner produces X, let the factory owner produces X package of screw X package of screw of type A and Y package of screw of type B, and let Z be profit. Now first, again question in a tabular form. We have screw of type A and screw of type B. Here we are producing X unit and here we are producing Y unit. Now to produce a screw, what I require? I require automatic machine and hand operated. So require use of two machines, automatic machine and hand operated machine. So automatic machine. Automatic machine and hand operated machine. Now automatic machine, it take 4 minutes on automatic and 6 minutes on hand for type A. 4 minutes and 6 minutes. So 4 minutes and 6 minutes, and second 6 minutes and 3 minutes. 6 and 3. So 4 minutes, 6 minutes, 6 minutes, 3 minutes. Total time automatic machine available is each machine is available for at most 4 hours a day. So 4 hours means total time 4 6 are 240. So this is the maximum time these machines are available. And as far as profit is concerned, when I produce type A screw, I will get rupees 7 and type B I will get rupees 10. So profit is 7 rupees 7 and here profit is rupees 10. So I will say we have to maximize Z is equals to 7x, so 7x will be profit on type A screw plus 10y will be the profit on type B screw. We have to maximize this, subjected to, now the condition is 4x plus 6y should be less than or equal to 240 and 6x plus 3y should be less than or equal to 240 and x comma y, this will be greater than or equal to 0. Now we will first draw these inequations. So here we have 4x plus 6y less than 240. So consider 4x plus 6y is equals to 240. This will give me, I can divide with 2x plus 3y is equals to 120. Now to plot, I need 2 points, x and y. When I take x0, I will get y60. When I take, when we take x0, I will get y as 3y is 120. So I get y as 40. When I put y0, I will get x is equals to 60. Now here 4x plus 6y, here 6x plus 3y. 6x plus 3y less than 240. So here we consider 6x plus 3y is equals to 240. This gives me 2x plus y, or as here it is 3y, keep 3y. Okay. So that will make my calculation easy if I have to find any intersection point. So here 4x plus 3y is equals to 240. Now I have to find x and y coordinate. So here I have x, y. When x is 0, 3y is 240. So 3 8s are. When I have y is 0, I have x is equals to. So this is 80 and this is 40. Right? When y is 0, 6x is 240. So x is 240 divided by 6. 6 4s are 24. So this is 40, 0. Now I will draw a graph. So on a graph paper, we will indicate these two lines. So for one, we have 40. So along y I have 4040. So what we do, we will mark here, say 20, 40, 60. Here we will mark 20, 40, 60. It could be somewhat more. So 80. Now 0, 40. Along x-axis 0, y-axis 40. So I will take 1 point here, and 60, 0. I will take 1 point here. I will join these 2 points by a line, something like this. This is my equation. 2x plus 3y is 120. 2x plus 3y is equals to 120. Now my inequality is less than 240. So 0, 0 satisfies. That means this side will be the feasible region. The second equation is 6x plus 3y is 240. So 0, 80 this point, and 40, 0 this point. So again I will draw a line, okay, which will pass through these 2 points. And as this is less than 240, so this is the feasible region. Now using these 2 lines and taking first quadrant as the required region, I will get this as the shaded area as the feasible region. They are intersecting at some point. Let us mark, this is point A, this is O, this is B, and this is C. So these are the corner points of this region. Now this area, you can see that this area is completely closed one. So this is called feasible region, bounded feasible region. Okay. So here coordinate of point A, O, B we know, but coordinate of point C we don't know. So here I will say that shaded region, shaded area or shaded part is the feasible region. Shaded part is the feasible region and corner points are there. So to get coordinate of point C, we solve 2x plus 3y is equals to 120. 2x plus 3y is equals to 120, and 6x plus 3y is 240. 6x plus 3y is equals to 240. Now these 2 equations we will solve. So when I subtract this equation from this, 240 minus 120 gives me 120. 3y minus 3y cancel. 6x minus 2x gives me 4x. So from here I get the value of x is 30, and from we can say that this is equation 1. So from 1, 2 into 30, 2x plus 3y is equals to 120. So this gives me value of 3y is equals to 120 minus 60 is equals to 60. So I get the value of y as 60 divided by 3, so 20. So my value of y is 20. So the coordinate of point C is 30, 20. Now to get the maximum profit, what next we will do? We will draw one table. Again we will draw one table in which first column is point, second column is z, value of z. Now z is the formula for z we have to maximize 7x plus 10y. So z is 7x plus 10y. Here the points are, we have point A which is 0, 40. We have so this point A I will write little down. I have point O which is 0, 0. I have point B which is 40, 0, and I have point C which is 30, 20. Now the value of z here I will get 40 into 10 is 400. Here value of z I will get 0. Here value of z I will get 280, and here value of z I will get 210 plus 200, that is 410. So I get maximum profit. This is the maximum value. So therefore our solution is z max is 410 at x is equals to 30 and y is equals to 20. So you can write in words. So therefore initially what we assume, let us just check. Factory owner produces X package. So therefore I will say, therefore factory owner produces $30 packages of type A screw and 20 packages of type B screw. Okay, so factory owner produces 30 packages of type A screw and 20 packages of type B screw, and his maximum profit, his or her, you can say, maximum profit is rupees 410. This is his maximum profit. 410 we got as the maximum profit, right? So this is how your complete solution is. So the important part is you frame mathematical formulation and then problem is simple to solve. Now a cottage industry manufactures pedestal lamp and wooden shades, each requiring the use of grinding cutting machine and a sprayer. It takes 2 hours on grinding cutting machine and 3 hours on sprayer to manufacture a pedestal lamp. It takes 1 hour on grinding cutting machine and 2 hours on sprayer to manufacture a shade. On any day, the sprayer is available for at most 20 hours and grinding cutting machine at most 12 hours. The profit from the sale of lamp is Rs 5 and that from the shade is Rs 3. Assuming that the manufacturer can sell all the lamp and shades that he produces, how should he schedule his daily production in order to maximize his profit? Okay, so again we have to find the number of lamps and shades manufactured. So I will say let cottage industry produces X unit of lamp and Y unit of shade. Now let Z be the profit. Now we will make a column, here lamp, here shade. We are producing, or cottage industry is producing X unit of lamp and Y unit of shade. Now what are requirements? Grinding cutting machine and sprayer. So the instruments required are grinding cutting machine, and sprayer. So on grinding cutting machine, 2 hours and 3 hours on sprayer to produce one lamp. 2 hours and 3 hours. 2 hours and 3 hours to produce one lamp, and it take 1 hour on the grinding cutting and 2 hours on sprayer to manufacture a shade. 1 hour and 2 hours. So for sprayer 1 hour and 2 hours. Now if we talk about profit and their total duration available, so total time, then sprayer is available at most 20 and grinding cutting machine for 12. So grinding cutting machine for 12 and this is available for 20 hours, and he will get a profit of 5 rupees on lamp and 3 rupees on shade. So rupees 5 and rupees 3. We have to check how many lamp and how many shade he will make in a day to get the maximum profit. So here our mathematical formulation is, we have to maximize Z is equals to 5x plus 3y. Now you understand how to formulate. We have to maximize, subjected to conditions are 2x plus y less than or equal to 12, because for maximum 12 hour grinding cutting machine is available, and for 20 hours, so 3x plus 2y, this should be less than or equal to 20, and the value of x and y should be greater than or equal to 0. X and y should be greater than or equal to 0. So these are the conditions which should be satisfied. Now Again you will draw these in equations, find the feasible reason, and then you can get what is the maximum profit is. Okay, here your area will be a bounded region, so easily you can get the answer. Now let us see the 7th question. A company manufactures two types of tires of novelty souvenirs made of plywood. Souvenir of type A require 5 minutes each for cutting and 10 minutes each for assembling, and souvenir of type B it require 8 minutes each of cutting and 8 minutes each of assembling. There are 3 hours 20 minutes available for cutting and 4 hours for assembling. The profit is ₹5 for type A and ₹6 each for type B. Souvenirs. How many souvenirs of each type should the company manufacture in order to maximize the profit? Okay, so the problem is exactly the same what we have discussed here. What we do, we convert this time in minute, right? So 3 hour 20 minute will become 3 6 are 180, 180 plus 20, 200 minute, and 4 hours, so 4 6 are 240, so 240 minute, and rest is exactly same as our previous problem. So you can try that problem. Now let us see this 8th question. A merchant plans to sell two types of personal computer, a desktop model and a portable model, that will cost ₹25,000 and 40,000 respectively. He estimates that the total monthly demand of computer will not exceed 250 units. Determine the number of units of each type of computers which the merchant should stock to get the maximum profit if he does not want to invest more than ₹70 lakh, and if his profit on the desktop model is ₹4,500 and on portable model is 5,000. So again we have to maximize. Now here the things given are a desktop model and portable model that will cost. So first cost is given and maximum amount which I have is ₹70 lakh. So the total cost should be less than or equal to 70 lakh. He estimates that the total monthly demand of computer will not exceed 250, means the maximum number of computer which he manufacture is 250. So the number of computer should be less than or equal to 250. Total computer, two type of computer, desktop model and portable model. So x plus y, if I consider x is the number of desktop model and y the number of portable model, then x plus y should be less than or equal to 250. Profit is 4,500 and 5,000, so 4,500 x plus 5,000 y. This is my profit that I have to maximize. So again you can do this problem. Okay, all the problems are simple, little lengthy, right? Okay, so now let us move to next problem. Question number 9. A diet is to contain at least 80 units of vitamin A and 100 units of vitamin mineral. Two food F1 and F2 are available. Food F1 costs ₹4 per unit and food F2 costs ₹6 per unit. One unit of food F1 contains 3 units of vitamin A and 4 units of mineral. 1 unit of food B contains 6 units of vitamin A and 3 units of mineral. Formulate this as a linear programming problem. Find the minimum cost for the diet that consists of mixture of these two food and also meet the minimal nutritional requirement. Okay, so whenever we have to minimize something, most of the time we will find that our solution is unbounded. Okay, let us see this problem. So what is my question? Find the minimum cost. Okay, and the cost is because of two type of food F1 and food F2. Okay, so unit of food, so let us consider, let a diet is contains at least this दिया है 2 food F1 and F2 are available. Okay, so find the minimum cost of diet. So let we take food type food F1 X unit and food F2 Y unit, and let Z be the cost. Okay, so let us first represent this whole information in table format. 2 food F1 and F2. So here we have 2 food F1 and food F2. Here in food we have vitamin A and mineral. So vitamin A and mineral. Now vitamin A for food 1 cost rupees 4. Acha, cost is also there, cost 4 and 6. So here we have cost. So let us first write cost rupees 4 and rupees 6. Now let us see what they contain. 1 unit of food F1 contains 3 unit of vitamin A, 3 unit of vitamin A and 4 unit of mineral, so 3 and 4. And food F2 contain 6 unit of vitamin and 3 unit of mineral, so 6 and 3. Their cost is given. So here we have to minimize. Z is equals to 4x plus 6y. Now food F1 we are producing X unit and food F2 we are producing Y unit. So 4x plus 6y is our maximum minimum cost. We have to minimize. Z is equals to 4x plus 6y. Subjected to few conditions are there. First is your 3x plus 6y. Now minimum vitamin required is 80 unit and 100 unit. So minimum requirement or total we require 80 unit and 100 unit. So subjected to 3x plus 6y, this should be greater than or equal to 80. Minimum is 80 required. So our total vitamin should be greater than this value. And 4x plus 3y, this should be greater than or equal to 100. And x and y should be greater than or equal to 0. So this is our mathematical formulation. Now we will solve. So 3x plus 6y is greater than or equal to 80. So we will consider 3x plus 6y is equals to 80. We will find the value of x and y satisfying these conditions. So x, y. If we take x 0, we get y as 80 upon 6, that is 40 upon 3. If we take y 0, we get x as 80 upon 3. Now the second inequation I have is 4x plus 3y greater than 100. So 4x plus 3y we have greater than or equal to 100. So for this we consider equation 4x plus 3y is equals to 100. and here also we find the value of x and y. So when we take x0, we get 3y is 100, that is y is equals to 100 upon 3. When I get y0, when I take y0, x is 100 upon 4. Now this 100 upon 4 is 25, and this 25 I can write as 75 upon 3. Now why I am writing in this form? Because every values are in the form of divide by 3 format. Okay, so it will be easy for me to plot. Now I will draw a graph. So let us draw a graph. So this is my graph. Now here I have to locate 0, 40 upon 3. So let this point will be 40 upon 3. So 0, 40 upon 3 and 80 upon, so this point is 80 upon 3. So I join these 2 points. With a line we will join. Then here we have 0, 100 upon 3. So 100 upon 3 will be somewhere, I will extend this line little up. Suppose here we have 100 upon 3 and 75 upon 3. So 75 upon 3 will be near to this 80. 75 upon 3. So I will join these 2 lines also. They will cut like this. Okay. Now our inequation is of greater than type, greater than 80, greater than 100. So if I take 0, 0, it will not be satisfied. So we should not look towards origin, we have to look away from the origin. So this side will be our feasible region. Now easily you can find out that this feasible region which I am drawing is unbounded. Now bounded means there is a closed boundary. Now here you can see that on right hand side I can shade any part. Okay, so no limit on the right hand side. So this is my feasible region. If I check the corner point, so I have one corner point A, one corner point here B, and one corner point here C. So to get the coordinate of point B, we have to solve these 2 inequations. So I will say that shaded area is my bounded region. Shaded area is the feasible region. It is unbounded. It is unbounded. Now I have to find the coordinate of point B. So to get coordinate of point B, we solve. So here to get the coordinate of point B, we solve 2 equations. One is 3x plus 6y equal to 80. So in equation format we will solve 3x plus 6y is equal to 80 and 4x plus 3y is equal to 100. 4x plus 3y is equal to 100. Now I can write this 4x plus 3y equal to 100 as 8x plus 6y is equal to 200, and from this I will get 5x is equal to 120, x is equal to 120 divided by 5. So 5 2s are 10, 5 4s are 20, so 24. And 3 into 24 plus 6y will be 80. So therefore 6y is equals to 80 minus 3 4s are 12, 3 2s are 6, 1 7. So 6y is equals to 8, y is equals to 4 upon 3. So this is the coordinate of point B. Therefore B is 24, 4 upon 3. Now I will find the value of z as at these corner points. So here we have corner point and we have z equal to, here we have to minimize what is total cost, 4x plus 6y. Z is 4x plus 6y. Now corner points are, point A is 0, 100 upon 3. So here we get the value of z as 6 into 100 upon 3 will give me 200. B point is 24, 4 upon 3. So here I will get z is equals to 4 into 24 plus 4 upon 3 into 6. This will give you 4 4s are 16, 4 2s are 8, 1 9 plus 3 2s are 8. So this is 104. And at point C we have 80 by 3, 0. This will give me value of z as 4 into 80 upon 3 plus 0. So this will be 320 upon 3. So 3 1s are 3, 3 6s are 18. So 106.666. So what is the minimum value? Minimum value is 104. Now this value 104 could be the minimum value. It depends on a condition that I will draw an equation and I see if there is any common point. So let us see what is criteria to find minimum or maximum value when the feasible region is unbounded. So here I will say that as feasible region is unbounded, to decide whether 104 is the minimum value, we draw an equation. So for this we draw an equation. Now what an equation we will draw? Z is 4x plus 6y. We will draw an equation 4x plus 6y less than or equal to 104. This I have to plot. So to plot this I will take xy. I will consider 4x plus 6y is 104. So when I take x0, I will get y as 104 divided by 6. So that is 52 upon 3. And when I take y0, I will get 104 divided by 4. So 4 2s are 8 and 4 24. 6 are 24. So 52 upon 3. So 52 upon 3 I will get a point somewhere here. This point is 52 upon 3 and 26 upon 0. So 26 by 0, 26 comma 0. So 26 comma 0 means if I convert in terms of divide by 3, so it will be 3 6 18, 3 2 the 6 1 7, 78 upon 3. So 78 upon 3 I will get point somewhere here. So when I join these 2 points, also as this inequation is solved for this 104, they will pass through this corner point. So passing through this corner point, if I join a line like this, and as it is less than 3 type, so I will see on this side. So is there any common point? We have to check if there is any common point between the feasible region and the inequation which now you are plotting. If there is any common point available, then in that case you will say that the value 104 which you got is not the minimum value. Okay, that means when there is some common point, in that case we cannot find the minimum value. Okay, and if there is no common point, we will say that the 104 which we got as minimum will be the correct minimum value. So as here, so as I will say that as no point is common, as no point is common between feasible region and inequation 4x plus 6y less than 104, we say z minimum is 104 at x is equals to 24, y is equals to 4 upon 3. So this is the minimum value of z, and at 24 comma 4 by 3. Right. So this is how you solve this problem. Now there is the last problem of this exercise. There are 2 types of fertilizer, F1 and F2. F1 contains 10% nitrogen and 6% phosphoric acid, and F2 contains 5% nitrogen and 10% phosphoric acid. After testing the soil condition, a farmer finds that he needs at least 14 kg of nitrogen and 14 kg of phosphoric acid for the crop. If F1 costs ₹6 and F2 costs ₹5, determine how much each type of fertilizer should be used so that nutrient required are met and at the minimum cost. What is the minimum cost? So here again the problem is of minimization. It is exactly the same as the problem number 9. So in that same way you will going to solve. So if I formulate, okay, you will say that key for fertilizer of type F1, okay, so just I will, in short I will formulate it. F1, F2, 2 types of fertilizer. Let F1 we take X unit, F2 we take Y unit. Now they have nitrogen and phosphorus. So nitrogen and phosphoric acid. So nitrogen is for F1 10% nitrogen. 10% nitrogen means out of 1 kg 0.1 kg is nitrogen. So in kg, and here phosphoric acid is 0.06 kg. For F2 we have 5% nitrogen, so that is 0.05 kg, and 10% phosphoric acid means 0.1 kg. Total nitrogen which I require is 14 kg. So 14 kg is my requirement for both the types. So this is total. And cost, if I see cost, so F1 type cost me ₹6 and F2 type cost me ₹5. So Z is my cost. I will say that we have to minimize. Z is equals to 6x plus 5y subjected to few conditions are 0.1 x plus 0.05 y less than or equal to 14, 0.06 x plus 0.1 y is less than or equal to 14, and the fertilizer which you manufacture or which you require should be non-negative, so therefore they are greater than or equal to 0. Now it is better that you multiply these equations by 100 so that you get integer values, and then it is easy for you to plot and find out. Here also you will get unbounded solution as minimum cost is required, so cost could go to any limit, so you will get unbounded region, and then you have to check whether the value which you got as the minimum is the minimum value, right? Okay, so I hope you have understood each and every problem in this exercise. Linear programming problems, okay, as far as 12th standard is concerned, they are very simple. Only you have to practice it so that in exam you can solve it in less time. Yes, thank you for being with me for this complete lecture. Okay, I will see you in the next lecture with a new chapter. Thank you once again.